So this is an angular momentum problem. We have a small child on a merry-go-round that's rotating counterclockwise with an angular speed of 3 radians per second. And we're told how far the child stands from the center, which is the point of rotation. And we're asked for the angular momentum. So there are different ways to calculate the angular momentum, and really it will be dictated by the thing you're studying, right? So the two formulas I gave you in class look like this, or like this. The first one is better suited to describe the angular momentum of a particle, or a point mass. Those mean the same thing. The second formula is more useful in describing, an extended object, so something with the shape, right? So the first thing that we should ask ourselves is, how do we model the child, right? And you would have to be told this in the problem or be given some sort of hint. So for argument's sake, let's just say we could model the child as a point mass. So we could go ahead and use this first formula. So the major issue, and it's not really that major, is this formula relates the angular momentum to the linear momentum, and we're told omega but not v. But that's not a big deal, because I know that the linear speed is related to the angular speed using this formula, where r is the distance from the point of rotation to the thing you're studying. So the linear speed of the child is going to be 0.1 times 3, or in other words, 0.3 meters per second. And then I could just go ahead and substitute everything else. So the mass is 5 kilograms. So another thing that I should mention is we're assuming in the problem that the child is staying there and it's rotating at the same angular speed as the merry-go-round. So this is 5, this is 0.3. This r is again 0.1 because it's the distance from the point of rotation, or the axis of rotation, to the thing you're studying. And the linear speed is going to be perpendicular to this distance r because it's rotating. So this sine of phi term is just going to be sine of 90, which is 1. So this is going to be 0.5, so 1/2 times 3/10, which is 3/20, which is, unless I'm mistaken, 0.15. And the units for angular momentum are a bit strange. It's a mass, a velocity, so meters per second, and then multiplied by a distance again.